Okay, let's get started then. So this is a meeting of COMSOC video seminar. So we have two speakers today. The first speaker is Umberto Grandi, who is here. The second speaker is Nimrod Talmon, whom I don't see at the moment, but hopefully he'll join us.
Here.
You're here, good.
Yeah. Hi.
Very good to see you as well. Okay, so we'll have the usual format of 20-minute talks followed by 10 minutes for questions. Then after that, a virtual coffee break where Dominic will use some Zoom magic to split us into groups so that we can talk to each other a bit, and then the second talk. Okay, so during the talk, so given the large numbers, I'm very pleased about the numbers. So we are 82 participants at the moment. During the talk, please don't ask questions out loud. So use the chat instead, right? So then the speaker may check the chat during the talk, but I wouldn't rely on that. The speaker is guaranteed to check the chat at the end of the talk. And if there's something in the chat that I think is urgent for the speaker to answer, I will be the one interrupting the speaker and asking him to answer that question. Right? And sometimes you get really interesting discussions in the chat during the talk. So usually it happens when the speakers, co-authors join the chat and help answer the question. Right? So if speakers, co-authors are present, yes, I encourage them to monitor the chat and feel free to reply. Right? And generally you can reply in the chat if you feel that you know the answer, so we don't have to wait till the end of the talk for the speaker to answer. So I see Arianna here, so she may be able to help with the first talk. I'm not sure about the second talk, but yeah, again, maybe someone will be able to help. Okay, very good. So do make sure you can see the chat. So in the chat, if you ask a question, please type it in capital letters, question. Try to do that. Question, everyone. Okay, so that's the format. Okay, and okay, so now that, all that has been said, I think we're ready to start. 14:05, so our first speaker, remember it's 20 minutes for the talk, 10 minutes for the questions, with obviously some flexibility built in. So I'm very pleased to introduce Umberto Grandi, who is an assistant professor, methodic in France, in Toulouse, University of Toulouse Capitol. And he'll be telling us about his work on multi-agent ranked delegations in voting. And this is joint work with his current and former students. And I think it's been recently published in a conference, trying to remember which one, AAR, ICHK, but one of the leading conferences. So welcome, Umberto, and tell us about your work.
Thanks. Yes, everything is said. So thanks a lot, Edith, for the introduction. And but thanks a lot to the organizers for this occasion to meet regularly with this great community and discuss about our work. So, right, so today I will talk about liquid democracy. This is the area, and more precisely about multi-agent ranked delegations. As Edith also said, this is joint work with Rachael Colley, who is doing a PhD here at the University of Toulouse. Here and on Zoom, but right, as it is now, and Arianna Novaro, who is now at the University of Amsterdam. Okay, so just to set the basic definitions, I guess most of you have by now heard about the liquid democracy, but let me just introduce very quickly what is the idea behind it. So in liquid democracy, voters have the possibility to delegate their voting power. And what is specific to liquid democracy with respect to proxy voting is that this delegation can be transitive. So voters can delegate their vote or their voting power or the delegations they received. So in the example over here, you have these two people delegating to this one who gets voting power of 3, her own plus 2, who can delegate in turns to this one, who gets all this delegation, who can delegate in, and so on. Good. I just wanted to mention that the term liquid doesn't actually come from the transitivity of delegations, but it was from one of the first implementations of this system on the liquid feedback platform, which is complemented with a delegation platform in which voters can discuss and update, so withdraw or retarget their delegation in a, say, liquid process. Anyway, this is just to set the stage of with the basic setting. It's a very simple idea, which has been studied recently quite a lot. I'm not, I will be partial in my review of very recent activities on this topic. If you see the years, it's all, a lot of papers came out in the past 2-3 years. So as many other social choice settings, it has been studied under 2 aspects, either as a truth tracking mechanism or as a preference aggregator. Okay, so the definitions stay the same, but the parameters we study are different. So our work is mostly in preference aggregation, but still I want to mention that there is a stream of paper trying to analyze whether delegations have a positive effect on the truth tracking. And my understanding of these papers is that the answer is probably not. So unless substantially modify the liquid democracy does not seem to be a better estimator than voting without delegation. Now, about preference aggregation, there are lots of questions that have been tackled. The first and more easier to understand is how much power should be given to the delegates. So at the end of the delegation procedure, we end up with a delegation graph, and the power of each of the voters who received all this delegation can be defined by the distance, by other many other ways. We will get to it later. So this is one of the problems that was tackled. The second problem is when voters have the possibility to delegate only or on parts of their ballot. For example, when we are voting on preferences, they might want to delegate only their voting power, so their expression, only on a subset of the alternatives that are there, still being able to express an ordering over the remaining ones. Or more generally, when you have multiple issues with a constraint, same problem, people might want to delegate on parts of the issues, so a subset of the issues, and the problem there is having the constraint satisfied with the delegation part. Third question, when liquid democracy can be studied with game theoretic tools. More specifically, we will see this later when more expressivity is given to the voters, where they can express rankings over delegates, not just the top one. Then this becomes a game, and then it can be studied game theoretically. So again, this is a partial overview of the literature, but it's just to show you that there's a lot of interest in this setting in the computer science, or say AI community. Okay, I'm gonna just look at the chat. Okay, so let me tell you how our work fits in this literature. I have 3 main motivation slides. It's going to take a bit of time, but still, I would like to stress how did we arrive at studying this problem. So the first question we were asking ourselves was concerned some of the work we were previously doing over here in Toulouse, which was about studying opinion diffusion on networks and in general models of social influence. So we realized that most of those works assume that the network is given and that the model of social influence is also given. I'm just giving example, threshold models, independence cascades, etc., etc. So the question here was actually, can we directly ask the voters or the agents? We use the elections as an example. Can we directly ask the voter to tell us who are their influencers and how are they influenced by it? Because these are 2 different things. I would get a network and a model of social influence, possibly different for every voter. So this was our first research question, and we realized that liquid democracy can indeed be seen as a simple elicitor of social influence, because the result we would have is a network, And social influence would be a very simple method, which is I have one influencer and I want to copy what this person does. So let's say this was the first angle. Second angle was something that was already debated in the literature, and we got. So I'm copying over here a picture that was presented at Daxel by now more than a year ago. What happens with delegation cycles? So this was a problem that was identified right away as a potential problem. So in the initial implementation in liquid feedback, cycles of delegations were ignored. If now I'm here, it's a bit more complex, but so if you follow the complete arrows, this person would delegate to this person, that delegate to this person, and we're back. So in the initial implementation, the vote of this 4-person would be ignored, losing in a sense losing some voting power. Or I mean, it's debatable why this what should happen. So it was first identified in a paper by Grossi and Christophe, who used backup votes to solve the problem. So if in a cycle, then there would be a backup vote to resolve the cycle. And more recently, by a paper by Kotzeloyu and Riley, and a working paper by Marcus Brill and co-authors, proposed to use ranked delegation. So this is what happens in this picture, where some of the voters can express a first delegation in case there's a cycle, a second delegation, which I write down as a dotted arrow, dashed arrow, and maybe a third delegation. And these are voters who actually vote. So as you can see, the picture becomes a bit more complex, and it becomes interesting to study how do I break cycles. There's not just a unique way, and many possible ways have been proposed by them. So here our question was, how can we assess those cycle breaking procedure, viewing liquid democracy as a preference aggregator, and investigate in general other polynomial procedures to break cycles. Third, we were, then I will actually present something. Third motivation we had, we were particularly excited about papers that were describing implementations of liquid democracy and elections in general as smart contracts. What does it mean is that, so what made us, the realization we had was that in liquid democracy, or at least in the implementations of liquid democracy, the platform itself is quite rigid in a sense. It's the platform that asks for delegation to the voters. While it would be more natural to imagine that voters can express whatever delegation they want, so that the delegations, as much as the vote, would be on the user side. And in this perspective, we would have to define languages for voters to be able to express delegations of arbitrary complexity. So this will become clearer in a second when I give you the actual definitions. Okay, so let me just tell you what is the overview of the remaining part of the talk. Let me just check. So, okay, I should have time. Okay, so I will give you the basic definitions of the setting, which we called smart voting, because we were particularly excited about this latest smart contract interpretation. Then I will present you some unraveling procedures, 4 in particular, and then I will present you the results. We analyzed this procedure algorithmically with computational complexity and very preliminary some axiomatic results. If you're interested in these results, the paper was presented a few weeks ago, actually, at ICHCAI 2020 in 2021. And we have a working paper with some of the results some of the extra results that I will present today. Okay, so here is finally the formal model. We assume a set of agents. We assume a set of issues that have to be decided, and every issue has a domain. So in the most general model, this is a multi-attribute collective decision. And here is our main definition. What is a smart ballot? What is what do we let agent express? So the first thing we included was the idea of having agent express ranked delegations. And the second thing we included is the possibility of expressing multi-agent delegation. So we tried to give the most general definition here. So a smart ballot then would be a linear order that consists of ranked delegation following by a backup vote. So here we took the idea of Grossi and Christophe to end every ballot with a backup vote, which is not such a big requirement, because the backup vote can be an abstention or can be voting for the status quo. So we didn't feel it was such a big requirement. But let's focus on the main part. So the ranked delegation consists of a set of agents and a function whose domain is this set of agents. Okay. We just have a basic notion of validity, which is that we require agents not to repeat themselves, so not to repeat the same aggregator multiple times, and self-delegation are not possible. But these are just basic requirements to be able to make sense of what the smart ballot would be. So let me give you a couple of examples now. So here is an example with 4 agents, a classical binary voting problem. They have to decide whether to try a takeaway restaurant or cook at home. So one issue binary domain. First, I can ask, like Cozzeloio and Riley, for ranked single agents. I want to delegate to the blue agent if this incur in a cycle, the light blue agent. If also this incur in a cycle, the orange agent, otherwise backup vote is takeaway restaurant. Or I can express another smart ballot, which would be using, this is the most general language we consider, an arbitrary Boolean function. I'm using a Boolean function because the domain is binary. So what is this purple agent saying now? I want to delegate to 3 agents, blue, light blue, and orange. And I agree with them. I agree with the blue agent if one of the 2, I'm mixing up things, I want to do as the blue agent and one of the light blue or orange agent. Okay. Said like this, it doesn't sound realistic, but if you think about it, that you might want to delegate in this way in some applications. And then it's ranked. So if this is not possible, if this occurs in a cycle, then to the blue agent and backup vote motorcycle. Last possibility is to use threshold, which is something also quite natural. I want to delegate to these 3 agents, and I actually want to do like the majority of them, right? This would be like a sort of collective intelligence approach where I leave my vote to those people. The majority of them will be right. Okay, so what do we do with these smart ballots? Remember that we let the agent express smart ballots of this form. We receive them. So here you have an example. We receive 4 smart ballots from the agents. And then we have to start, we propose unraveling procedures that take those ranked multi-agent delegations and give us a direct vote, a profile of direct vote on which we can use whatever rule we might want to use. Still, this is well, it would be a plurality like ballot, or in binary voting, we would use the majority. But so these are the objects we would study. Unraveling procedures that take ranked multi-agent delegations and give us a profile of direct votes. So we propose 2 rules based on 2 unraveling procedure based on minimization and 4 greedy procedures. So the 2, it's not very surprising. The first 2, it's what we would actually do whenever we have a ranked profile. The optimal unraveling would minimize the sum of the ranks of the delegation used. So we would try to use, on average, the highest delegations as possible. Min-max would do the same, but minimizing the rank of the worst of delegating agents. So we don't want to use the first delegation for everyone and the very last for one of the agents. So this would be two, as you can imagine, computationally hard rules. And then we define 4 greedy procedures that are polynomial. And to define them, we use 2 principles. One is try to give a priority to the expression of direct votes. And the second is whenever we can add only 1 voter at a time. So this is to avoid, this is exactly what I said. Okay, so for the results, I think I have 5 minutes left, a bit less. I'm gonna just give you a preview of the results. Algorithmic analysis. So all the proposed unravelings are disjoint, which is not trivial to realize. However, they do coincide if there is only 1 single agent delegation per voter. So the classical liquid democracy setting, they all coincide except for min-max, which would break cycles in a different way. So this means that we really need ranked delegation or multi-agent ones to obtain a different result. Second, computational complexity. So all the greedy unraveling, all the 4 unraveling procedures take polynomial time with the most general language, which for us was allowing arbitrary Boolean functions on binary domains. The opt and min-max, as maybe as expected, they are NP-complete on the general language bool. But if we focus on single agent ranked delegations, then they are polynomial. So there is a nice jump there, which comes from multi-agent, allowing for multi-agent delegation, because here we still have single agent ranked delegation, and it's still polynomial. Okay, last, this is rather preliminary. We studied, we wanted to compare with the 2 functions, with the 2 procedures proposed by Kotsiolowo and Riley, depth first and breadth first procedure. So we did this, we took their axiomatic study of participation, 2 notions, caste participation and guru participation, which is whether a person has an incentive to participate in the election and whether a person has an incentive to accept the delegations. And we did this study only for single agent ranked delegations. Okay, I can go back to these results in the discussion if you are interested in it. I have also an example of one of those unravelings if someone wants to see it and if there is time. So let me just recap. Our 3 research questions were: try to elicit directly social influence structure from agents, investigate cycle breaking procedures, and defining arbitrary languages to express complex delegations. And so our setting is as general as possible, and it allows for multi-agent ranked delegation, and the main object of study for us is unraveling procedures, so how to unravel a profile of smart ballots, ranked multi-agent delegations, into a profile of direct vote. And that's all. I'm happy to take questions or to read in the chat.
Right, okay.
Your questions.
I would ask everyone to unmute their mics and give Umberto a round of applause. Now let me be a bit of a dictator. In the chat, we already had a request for an example, and Umberto promised an example, so I think that's a good place to start. Perfect. Then I also see that Arianna did a perfect job replying to everyone in the chat, so thank you. Okay.
Almost everyone.
Okay, great. So, okay, so here is an example. This is one of the greedy unravelings. Here is a profile of smart ballots. We have A, B, C, D are our voters. A is delegating to B and C, so wants to do exactly as A, B, and C. Remember that it's binary domain. Second delegation of A is D. Third is direct vote of 1, backup vote of 1. B directly votes for 1. C delegates to D. D delegates to A. Okay, so there's a cycle. To decide A, I have to know what C thinks. To decide what C thinks, I have to know what D thinks, what A thinks, and I'm back there. Good. So in the first step, I just basically initialize the vote of everyone to nothing. And then I look at the first delegation and I check if there is a direct vote, and I add it. So this is my first step. I prioritize the direct votes of people. So those that actually felt confident and expressed a vote. Then at the second step, I check whether I can compute any of the votes. And at the first preference level, it's not possible because to compute A, I still need to know what C says. So the cycle is still there. And then what I do is that I descend to the second preference level. And in the second preference level, I can add the direct vote of C, as well as the delegation of D to B. So this I will add because it's a direct vote, and the direct delegation of D to B can be computed from the partial vote I was storing. So that's what I'm doing. I add the vote of B, B voted directly. I added C as 0, direct vote here, and D as 1 because wants to delegate to B. And then I can go back to the first. So I say, well, I mean, I backtrack and I can now evaluate A's formula or A's delegation, which is 0. And I end up with profile of direct votes. So just to tell you what the rank of a delegation is, I use the first rank of A, the first rank of B, the second rank of C, and the second rank of D. So overall, I would have a total rank of 6 if I am in the first procedure.
Okay, great. Ariel, does this answer your question? Okay, good. And while Umberto was explaining this, I think I saw 3 more questions in the chat. I think, Umberto, you'll be comfortable reading them yourself, or do you need my help?
Yes, I will. I do. So Peter asked, how about trust in such a system? Okay, so one of the possible implementation we had in mind, but we didn't do it. And two of the cited papers actually talk a lot about trust. If with trust, you mean security. Describe how, so those smart ballots should be written in some self-executable code and submitted on a public ledger, so that at the end, when all the ballots have been computed, they actually execute themselves, and the final vote is computed. Okay, that's a
thinking
more of a
about
vision
something other meaning of trust in how do you reflect the fact whether voters indeed trust the people they are delegating to.
Well, okay, I see. Let's say that the whole system is based on the fact that if you do delegate your voting power, you do trust them to delegate to another person that they trust and so on. Maybe in the initial setting where actually delegations were liquid, this trust was actually built on the deliberation that preceded the vote.
Trust isn't necessarily transitive. So if I delegate to A delegates to B, I mistrust B, there's a problem.
Yeah, so the fact that this is transitive, it's an assumption to make. Yeah.
Thanks.
So Ule asked, is there a connection between the local aggregators and the high-level aggregation rule being implemented in the system? I don't know. We haven't actually studied anything about the global aggregation. We just output a profile of plurality style ballot or binary votes.
I was thinking about something like, if the local aggregators all satisfy Pareto, do you also satisfy Pareto in some sense at the global level? Maybe stuff like this.
Yeah, okay. Then our preliminary axiomatic study was exactly like this. We had to assume that the final rule, for example, satisfied cast participation, so that the whole system would satisfy cast participation. But we haven't gone much far there. But yeah, that's the way to study the axiomatic properties then. Thanks for the question. Okay, I will, if I still have time, I will read the Vincent question. So it's a high-level question. In principle, you could make the smart ballot language richer and richer. What is the ultimate goal? If the ultimate goal is to predict what I really would want to vote if I had fully done the research myself, in principle, what one might take other things into account as well to do the prediction as well as possible. But is this the right goal? Okay, so a high-level question requires high-level thinking. So maybe this question is more towards the truth tracking interpretation, but still, I would actually say that the goal is just to give more expressivity to voters who might not want to think about how they would vote, so that they are able to express more general delegations, not just to a single person, but to more. Then you are right that there is no upper bound. We can use a smart ballot. If we define any language, the smart ballot can be any language, then the only, how much they can take into account, it's a good point. Yeah, I don't think I actually replied to the question, but it's an interesting thought. Yes, there is no limit in a sense.
Yeah, there's certainly food for thought there. And now maybe a quick question towards the end about negative votes. Not the very last one, but next one.
The one by, so if several
Again by
people,
Earl. So the question is simply, do you allow negative votes?
like negative influence, yes. So it is possible to use negated literals in the formulas. So it is possible to say that you want to vote like A and B, but only in case, like A and the opposite of B. Yes, it's possible. So one thing we discussed was to study a language between simple delegation and full Boolean delegation, which would be just positive formulas in which this kind of negative influence would not be possible.
I think there's also an interesting example in the chat of when delegation kind of isn't really transitive. So one may need some knowledge of Israeli politics to understand it. So I think that's best left for the coffee break discussions. So we had our 10 minutes for the questions. So I think let's close there, unmute once again for a second round of applause to Umberto. Thanks, Umberto, for a great talk.
Thank you. Thanks.
Okay, so
shall I share the slides, Edith?
Sorry?
Shall I share the slides?
Yeah, go ahead. Yeah. Okay, so the second talk of this seminar is by Nimrod Talmon. So it's on another hot topic in computational social choice, namely participatory budgeting. So the title is Participatory Budgeting with Project Interactions. I think at least one of Nimrod's co-authors is also at the seminar. I think I've seen Krzysztof. So there will be someone to answer your questions in the chat. Okay, so let's get started. 20 minutes plus 10 minutes questions. Welcome.
Thanks, Edith. Thanks, Edith, and thanks for inviting me to this nice venue. So actually, also Christoph and Pallavi should be here. So if you do have questions, they will be happy to answer, and I can also try to answer at the end. Okay. So maybe some of you, or most of you, know what is the idea behind participatory budgeting. The basic idea is to somehow decide how to use public money by means of direct democracy and not, let's say, in the confined premises of the city hall or something like this. The first time it was implemented, it was in Brazil in the 90s. But since then, it's been applied to many, many places. So I put here a figure from the participatory budgeting process in Paris, because I think in terms of the amount of money that is being decided using participatory budgeting, this is the best example. And I also put the example from one of the projects from Gdansk in Poland, actually because my grandfather is from there, and then I realized that they also do participatory budgeting, so I wanted to put it there. I also put another thing here, this pabulib.org, which is a project that Stanislav Shufa manages, and basically we take real data from participatory budgeting and put it there. So it's like Preflib for participatory budgeting, if you want to think about it this way. Okay, so let me give you a quick example of how participatory budgeting is done usually in the world. This is from Cambridge, from by now already 5 years ago. You can see here the rules of the vote. The way it operates is that usually there are two phases. In the first phase, each, say, a resident of the city of Cambridge can propose a project, and then the city administration puts a price tag on each of the projects. And then there is the second phase, which is, let's say, more interest, at least from the computational social choice point of view, in which people can vote on which project they want to fund. In the example of Cambridge, you see here part of the ballot. So actually there are many projects being proposed. And here you can see 10 of them. And you can see, for example, to build new furniture for some library. This is one of the projects, and it costs $36,000. And there are many other projects. And basically each voter comes to the ballot box and across at most five of the projects. And then the city gathers all of the ballots and decides upon the winner. How do they decide which of the projects shall be funded? Basically, they do what I call greedy approval. They take all of the projects, they order them in descending order of the number of votes each of them got. So for example, the project who is to fund, to build or to plant 100 new trees got this amount of votes. And then the second project that got many votes is this project about computers that got slightly less than the first one, and so on. So this is the order of the project by the number of votes each project got. You can see the cost of each of the projects. So then after the city order all of the projects by descending amount of number of votes, they simply go from top to down, and they fund as many projects as they can until the budget limit that they set aside for the process of participatory budgeting is exhausted. So in this example, they decided that they will have $500,000 being spent on this process of participatory budgeting. So they decided to end just above this project of Wi-Fi, but then the city said, okay, we can also add this $27.4 thousand and also fund this project. So this is the way they did it in Cambridge, and this is the usual way that they do it all around the world. So formally, the model is as follows. So I call it combinatorial participatory budgeting, following the nice survey of Harris and Nissan, if I remember correctly, because I think maybe it was, actually I don't know if it was last week or 2 weeks ago. So there are also other models about budgeting in which the projects are not indivisible. They are divisible, and this is different than this kind of project, this kind of model. So I adapted the name combinatorial participatory budgeting, and the model is as follows. So we have a set of items or projects, P1 to PM. We have a cost function giving how much money each of the projects costs. We have a set of voters. In this talk, I will concentrate only on approval ballots, but you can imagine that maybe in other settings of participatory budgeting, people want the voters to give the preferences in different kind of ballots, but let's concentrate on approval ballots, which means basically that each vote gives a subset of the projects. In the example of Cambridge, this was a subset of at most 5 projects, but let's be general and say that each voter can give as large a subset of voters that she approves of. And now given this kind of input, and also a budget limit, which is the amount of money that let's say the city wants to spend on the participatory budgeting process. In the Cambridge example, this was $500,000. So given the items and the cost of the items and the voters with their approval ballots and the budget limit, what we want is some budgeting method, some aggregation method, or some voting rule that returns a solution. A solution is simply a bundle of the projects, of a subset of the available project. And the only requirement that we require is that the total cost of the projects that we fund respect the budget limit. So this is the formal model of combinatorial participatory budgeting for approval ballots. Okay, so the main point of view of this paper and the talk is that there are some aspects of participatory budgeting that are neglected in this formal model and correspondingly in the way that participatory budgeting is being done usually. And one of them is the issue of project interactions. So the way participatory budgeting is somehow implemented and thought of is that there are projects, but there is no interaction or relations or dependencies between different projects. But this is sometimes not true. So for example, there could be one voter that says, okay, so I would be happy with funding a school, so I would approve funding project P, which is to fund a school, but I will only use the project. I mean, I will only be happy with this school if there will be another project, namely a bus stop next to it that will be also funded. So there is project, let's say project P1, which is to fund the school, and project P2, which is to fund the bus stop, to build a bus stop. So this voter can simply approve the school and the bus stop, so P1 and P2 together, but there is no guarantee that indeed the P1 and P2 will be funded together or not funded at all. So it could still be the case that even if many people want these two projects together and they think that they should be together, still in the solution, we will select only one of them, and then these voters maybe will not be happy. And maybe more generally, the true preferences of the voters will not come into account when we select the winning bundle. So this is one type of interactions between projects or dependencies between projects, which I call complementarity. So basically a positive synergy between projects. And there could be another type of project interaction, namely substitute. So for example, one voter can say that, so I would like to build a park, and actually maybe even I don't care whether to build park A or to build park B, or maybe I do have preferences that I want one of them more than the other, but I surely don't want to spend the public money on funding both. Maybe these two parks are geographically speaking next to each other. So there is no point in funding also project P1, which is park A, and also project P2, which is park B. So now this voter has the decision to make which one of these parks, or whether two of them, to say that she approves of, to vote for. And there is no guarantee that indeed this kind of preferences about this substitute effect between these two projects will be taken into account. So in the standard way that participatory budgeting is being made, and this kind of preferences that concern the interaction between projects are not being taken into account. So this was the starting point of our work. And what we come up is this generalization of the standard model of combinatorial participatory budgeting. So what you can see here in white is exactly what we had before. So we still have the project and the cost function and the voters and the budget limit, but we also add on top of it a partition, we call it Z, of the projects. So we have project P1 to PM, and furthermore, we have a partition of the projects. And the way to think about this partition is that this gives the structure of the interaction between the projects. So for example, if P1 and P2 are somehow related to each other, then we will put them in the same part of the partition. And if P3 and P4 and P4 are together, let's say substitutes or complementary, so there is some relations and dependency between these projects, then we'll have another part of P3, P4, and P5 together. Okay, so given this kind of an additional partition Z over the set of projects, this interaction structure, then how should we take the degree of substitution effect or complementarities effect into account? There are many ways that we can do this, and we went into the following way. So we fix some function f, and now we take the, let's say, simple utilitarian approach, where basically what we want to select a bundle. So we think about an aggregation method, that will take into account the interaction structure, this additional partition, and we'll try to maximize the voter satisfaction or the utility of the voters, or the summation of the utilities of the voters. And now the question is, what is the utility of the voters? So let's give an example. So let's say that the set of projects is P1 to P10, and we have this kind of partition. This is the interaction structure of the instance. So P1, P2, P3 are together one part, P4 to P8 are the second part, and P9 and P10 are the third part. So for example, it could be that P9 is the school, and P10 is the bus stop that is next to it. And now we define the utility of a voter from a possible bundle. So let's say that there is one vote that votes for these projects. So there is a voter that approves P1, P2, P4, P5, and P9. And there is a possible solution, possible bundle, which is P1, P2, P4, P7, and P9. And what we want is to define the happiness or the utility or the satisfaction that this voter gets from this possible bundle. And at the end, what we will want to find the bundle that maximizes the sum of the utilities of all of the voters. So what is the utility of this voter over this, with respect to this bundle? So we go part by part. So let's start with the first part. Let's see how many of the projects from the first part that this voter likes are really funded at the end by the bundle. So in this example, you see that voter V approves of P1 and P2, and indeed in the bundle P prime, we have that P1 and P2 are being funded. So there are two projects from part one that are being funded. So now the utility of voter V from this part one with respect to this bundle P prime is the value of the function f of the number 2, right? Because he got, or she got, two projects funded from the set of projects in part one that she approves of. And now we also consider the second part. In the second part, this voter approves of P4 and P5, but in the bundle, there is only P4 that is being funded. So there is only one project being funded from the set of projects that are approved by voter V in part 2. So the utility of V from part 2 is only f of 1. And the same for part 3, it's f of 1 because there is only P9 that is approved and being funded in part 3. So now we have the utility of V from each of the parts separately, and we simply sum them up to arrive to the definition that the utility of V from this bundle or from this bundle P prime is simply f of 2 plus f of 1 plus f of 1. So now given some specific function f, we have a concrete definition of what is the utility of a voter from a bundle, which takes into account this partition into interaction structures. And now what we want an algorithm that will find the bundle that maximizes the summation over the voters of the utility, right? So we want to find the bundle P prime that will maximize the sum of the utility of the voters from this bundle. Okay, so these are the interaction functions and how we define the utility of a voter from a possible bundle and what is the aggregation goal, what is the algorithm that we are looking for. And now indeed the most important ingredient in this is this function, and we can have it, I mean, this is a parameter of the combinatorial problem, if you will. First, we do have three, I think, simple and natural requirements from this function, these interaction functions. First, we require that f of 0 will be 0. I think that it makes sense because otherwise it means that I get some utility from a part even if there is no project that I like in this part that is being funded. So if in some part there is no project that I like and is being funded, then my utility from this part is 0. Second, we want this function to be non-decreasing, which means that as there are more projects being funded from the set of projects that I approve in some part, then I will be more happy and more happy, or at least I will never be less happy. And the third requirement is basically for some kind of normalization. So there could be a function that starts in zeros and continues being in zeros, but for the first index in which it's strictly above 0, it shall be 1. So this is kind of a normalization factor for these functions. And now maybe the basic observation or just a sanity check is to see that if indeed there are no interactions at all, then this would correspond to the function which is the linear function. So f of 1 is 1, f of 2 is 2, f of 3 is 3, and so on. So now let's go back for 1 minute to the last slide to see what would it mean for this function in this example. So you can see that this voter, okay, so for this voter, we said that it gets f of 2 plus f of 1 plus f of 1. If f is indeed the linear function, then it means that the utility of this voter from this bundle is simply 4, right? 2 plus 1 plus 1, because f is the linear function. And you can see indeed that the number of projects that this voter approves and are being funded without regard to this partition to the interaction structure is 4. So indeed, if we take the interaction function f to be just the linear function, then this is equivalent to not considering the interaction partition z at all, because we don't take it into account if the function is linear. But if the function is not linear, then things become more interesting. So for example, let's say that f of 1 is 1, which means that if I get one item funded from one part that I like this item, then I get a utility of 1. So now let's think about f of 2. If f of 2 is 2, then this is just linear, so it's without interaction or without taking into account substitution or complementarities effect. But if f of 2 is greater than 2, for example, if f of 2 is 3, then this would correspond to some complementarity effect. This would correspond to the setting in which if I get just one project, then my utility is 1, but if I get 2 projects, then my utility is 3. So it's strictly bigger than 2. So complementarity is just that the sum is bigger than the parts. But if, on the other hand, if f of 2, say this is still 1, then this would correspond to substitution effect in the sense that this is a diminishing return. So as I get more project from this part that I like, my utility grows smaller than linear. Okay, so indeed, we kind of distinguish between two types of functions. So if the function is concave, then this would correspond to substitution effects. But if the function is convex, like this function, this would correspond to complementarity effect. And okay, so this is our modeling of complementarity and substitution effects for participatory budgeting using this utilitarian approach. Okay, so then we basically wanted to see whether we can really compute this kind of winning bundles when we take into account this substitution effect or complementarities effect. And indeed, I mean, the first observation is indeed, if the function is linear, then this is simply the standard case of participatory budgeting, and this can be solved in polynomial time using dynamic programming. It was basically equivalent to knapsack when one of the dimensions is unary. So this would mean that we basically want to maximize the number of hits. So the utility of a voter is just the number of projects that the voter likes and are being funded, and we want to maximize it over the voters. And this is really like knapsack, and we can solve it in polynomial time. And then we thought, okay, so maybe for some of the functions, we can still solve it in polynomial time somehow to generalize this dynamic programming or generalize the knapsack equivalence to some other function. But it turns out that even if we deviate only slightly from linearity, then we hit immediately NP hardness. So this is the bad news. And then basically we wanted to see, again, what can be done, and just to maybe to give the overall approach is the following. So participatory budgeting without the interaction effects or without the project interactions can be solved in polynomial time. And the point of view is somehow to see how complex kinds of interaction can we accommodate while still being able to compute it efficiently. So to somehow try to find the special cases or the settings in which we can incorporate project interactions efficiently. Then we consider parameterized complexity, and we consider approximation algorithms, and we consider some restricted domains, somehow to restrict the kind of profiles or the ballots that voters can give us, and also restricting the structure of this function f, of this interaction function f. Okay, and we get roughly these results. So there are some more results in the paper, but I think these are the nicest. So if the size of the part is small, so let's say that take the size of the maximum of the largest part in the partition Z to be the parameter, then it turns out that we can indeed solve this in FPT time. And the algorithm is quite a natural dynamic programming algorithm, which basically works because if the size of each part is not too big, then and if the function gets only integer valued functions, this is why we have this asterisk here, then it means that the utility that the voter can get from a specific part is also bounded. And then we can do the dynamic programming on this kind of utility, and it's not too large, so we can still do it efficiently. So it means that if, say, some city wants to do participatory budgeting with some interaction effects, but the size of each interaction effect is not too big, then this can still be done efficiently. The next kind of parameterized algorithm that we have is for the number of voters. So if the number of voters is not too big, then we can still solve the problem efficiently. Of course, in standard participatory budgeting settings, the number of voters could be all of the residents of some city, which is usually a big number. But I think that this makes sense for other settings. For example, if you want to do participatory budgeting in some kind of a small group of people or small committee that want to decide it, then the number of voters can still be rather small. And then we can solve it with a combination of dynamic programming and a mixed integer linear programming formulation.
Nimrod, I suggest that you still allocate some of your time budget to questions.
Sure. Yeah, so I didn't look. So I'm already after 20 minutes?
Yes.
Okay. Okay. So I will just take half a minute just to say that we also wanted to consider some domain restriction which are specific to the setting of project interactions. And one of them is this district. So if you imagine, I mean, this is a very restricted kind of domain restriction, but if you imagine then that you have a city with districts and each voter will only vote for projects in her district, then also we can solve it in polynomial time. This is, of course, a very restricted domain restriction. Also, we have standard greedy approximation for concave function because then we have some modularity. And then I can really finish to say that I think that the bottom line is that indeed we can incorporate project interactions to participatory budgeting, at least sometimes, at least for this kind of an approach. Other things that I think are important to check is whether there are other kinds of solutions or other ways to somehow try to incorporate project interactions to participatory budgeting. A different kind of thing, or maybe related, is whether we can achieve it while still having the solution being proportional, which is not the case in this utilitarian approach that I discussed. And maybe further and more general, there is still the question whether these kind of substitution effects and complementarities effects are really the most natural and the only kind of interactions between project and participatory budgeting, or maybe there are other kind of interactions that also, if we could incorporate them into participatory budgeting processes, will improve the, let's say, the social welfare even better. Okay, so this is basically what I wanted to say.
Okay, great. So let's unmute and give a round of applause to Nimrod. Really nice talk. We still have 5 minutes left for questions, and I think there are nice questions in the chat, not all of which have been completely answered by Christoph.
Okay, so shall I go over, or do you want to tell me?
Let me see. So there's a question from Umberto towards the end that I think hasn't been answered. Or right, no, so I think it will still merit an answer from Nimrod.
PB organizers typically choose the simplest tool, how to convince them to use an approximation algorithm if they don't understand or cannot explain to voters. I see. Yeah, so this is actually a very good point, I think. Let me try to organize my answer. So I have several thoughts about it. So I will answer without really good structure of the answer. But first thing, I think that voters will be more willing to use rules that are more complicated for more complicated tasks. For example, it would be harder to convince voters to use a complicated voting rule, let's say the Dodson, for single-win elections. But for participatory budgeting, I think that it makes more sense because somehow people appreciate that the setting is hard and complex to solve. I mean, people are also willing to use algorithms that they don't understand when they use GPS, right? So maybe in the same kind of way, they will also be susceptible to complicated voting rules for these kind of settings.
Okay, so I think, so let me kind of summarize these comments myself. I think there were several comments in the chat concerning whether one can make this framework more flexible, like allow voters to specify their own partitions, allow different voters to have different FI functions. So what are your thoughts on that? Kind of how much further can this framework be pushed?
I see. Yeah, so this somehow comes in at least philosophical point of thinking, like the talk of Umberto, right? So at least my take on smart voting is that we want, let's say, a tool that will allow for extreme flexibility from the voters. And in this way, then if we add like a global interaction structure and a global F function, that this pushes it a little bit, maybe we want to push it more. So I remember that we discussed it, I mean, with Pallavi and Christoph, but I don't remember the bottom line. So what could be made and what could not be made. So without putting money on it, I think that at least for some of the simple settings, you can allow voters to specify their own partitions and their own functions as they wish. What also I think that could be done and still could be computed efficiently is to have a different function to each of the parts, which is maybe even more needed, right? Because you can then have one part which is substitution, another part which is complementarities, and so on. And actually, so the way I view it, there are two ways to do this. So one of them is to have each voter to specify their own functions, but maybe a different way is to somehow hold the preliminary election on these functions and on the partition, and then do this global kind of functions and partition. So hopefully this answers a little bit this type of questions.
Okay, thanks. No, I can see there is an interesting conversation in the comments, kind of continuing kind of various lines of questions between Christoph and everyone. But does anyone have questions at this point specifically for Nimrod? Maybe in the interest of time, just, you know, use your voice to ask or type something. I think we can still afford maybe one quick question. Anyone? No? Okay, so then let's conclude this talk. So that's right. So let's thank Nimrod again. Good, better when you unmute. Right, and now we have some announcements. So I'll give the floor first to Bill Zwicker, and I think has several announcements to make.
Yes, I want to mention that the next instance of this seminar will be 2 weeks from today at the regular time. Our speakers will be Franz Dietrich on dynamically rational judgment aggregation and Sean Horan on two-stage majoritarian choice. I also want to remind you of the February 5 to 6 virtual conference on social choice and applications. It'll include a number of speakers from the past of this seminar and the future of this seminar. The website was listed in the email that Edith sent to you on Monday, or you can shoot me an email and I can tell you where the website is. That's for February 5 and 6. And I think that's all I had to say. Edith?
Then we have another announcement then from Rachael, who basically wants to advertise the next COMSOC workshop. So they want to say a couple of words?
Yeah, so just COMSOC 21, I think we may have announced it, but we launched the website, so you can see all the details and call for papers there. We'll also send the call for papers through the regular networks, okay? That's it.
Okay, then I think that's all for today. Thanks everyone for attending. So I think we had 2 fantastic talks, kind of great number of attendance, great interaction. So the next seminar will be in 2 weeks. Hope to see many of you there. Thanks.
Thanks.
Bye-bye.
Thanks.
Bye-bye.
Bye.